When do the try, catch, and finally code blocks run in C#? We'll investigate to see if the code block always runs. But first, let's have a look at the try code block and its purpose. The purpose of the try code block is to write code where there is a risk of an exception being thrown. There are many reasons as to why you want to do this. One example is if you're communicating with a service outside of the application, such as a database or web API. These are prone to unexpected issues, such as connectivity or resource management problems. The catch statement ensures that these exceptions can be handled without the application crashing. Let's have a look at an example for this. So we're going to make an API call. To do that, we're going to create a new instance of the HTTP client. To make the call, we're going to do it in a try code block. So we're going to call http client.getAsync. We're going to call that URL. And we're going to ensure that it's a successful status code. Any exceptions that get thrown within the try code block are going to be captured in the catch code block. We're going to write the exception message to the console application. So now if any exceptions get thrown within the try code block, the catch code block will run and it will write the exception message to the console application. Running the console application, it's making our API call. It's done that successfully, so now it's checking to see if we've got a successful status code back from the API call. It's thrown an exception saying the response status code does not indicate success, 404 not found. It's now running the catch code block and it's writing the exception message to the console application. Looking at the console application, we can see that that message has been written. As well as the exception class, C# has a number of other common exception classes that you can use. They include argument exception. This is where one of the arguments provided to a method is not valid. Divide by zero exception. This is attempting to divide a number by zero. Index out of range exception, attempting to get the value of an array index that is outside the bounds of an array. Null reference exception. This is using a null reference object in a way that requires an instance, such as calling a property or a method. Out of memory exception. The application cannot allocate enough memory. Any of these exceptions can be handled in a separate catch code block. Let's take a look at an example for this. In our getCategoryName, we're passing in a category type as a parameter. We want to return the category name, so in the try code block, we're going to return the category name. Now we want to catch exceptions, but only if a null reference exception is thrown. If it is, we return null. So if a null reference exception is thrown, it will return null. But if any other exceptions are thrown, it's not going to run the catch code block and it's going to go unhandled. But to mitigate that, you can add multiple catch code blocks to a try statement. Back to our example, we're going to add another catch code block and we're going to capture any other exceptions. If this was to happen, we're going to write the exception message to the console application, then return null. So if a null reference exception is thrown, it's just going to return null. But if any other exceptions are thrown, it's going to write the exception message to the console application, then it's going to return null. You can also add your own exception class. One of the benefits of creating your own is that you can add members that are specific to that exception. Let's see on how we create one. We've created a category exception class, which is inheriting the exception class. We have a read-only category name property, and this is being passed in as a parameter in the constructor and being set. The constructor is also calling the exception base class with no parameters. To add the exception message, we create a new constructor. We're going to pass in the category name and also the error message. To set the error message, we call the base exception class and we set the message parameter within it. We're going to set the category name property as well. Now to set an inner exception, we need to create another constructor. We need to pass in the inner exception, which is a type of exception. And we call one of the other base classes, so we call the one that has the message and the inner exception. And that's how we add the inner exception. We can add that exception as a separate catch block. So we call catch and we're going to catch the category exception. And then we can do what we want within that catch block. So we're just going to return null. Now that we've examined how the try catch statement works, let's examine on when they run and how the finally statement works. In this first code block, it's adding two numbers together and setting it in a variable. As this does not throw an exception, it doesn't run the catch code block and it goes straight to the finally code block. With this, it attempts to pass in a number that is not a number. This throws a format exception, so the variable of b will never get set. Instead, it goes straight to the catch code block and writes the exception message to the console application. It still runs the finally code block and sets load to false. This next one behaves differently depending on the application that you're using. We're using a console application and we're attempting to pass in a number that is not a number. This will throw a format exception, but we're only capturing an exception if it's a null reference. As a result, it's crashing the application and it's not running the finally block. In an ASP.NET Core Web API, it behaves slightly differently. Once again, we're trying to pass in a number that's not a number. We're only capturing the exception if it's a null reference exception. This is going to throw a format exception and it goes unhandled. However, it still runs the finally block, so that's the difference between the two. It's a similar story with this next scenario. We're passing in a number that's not a number. We're capturing the exception, but then we're throwing the exception. As a result, the exception goes unhandled and it's not running the finally block. That was in a console application. In an ASP.NET Core application, it behaves slightly differently. So once again, we tried to pass in a number that's not a number. It catches the exception, then it throws the exception. This comes up with an unhandled exception, but it still runs the finally code block. So once again, the difference is that in an ASP.NET Core application, the finally code block is run, whereas in the console application, it's not. Back to our console application, we're passing in a number that's not a number. Notice that we're not capturing any exceptions. It's throwing a format exception, which is going unhandled, and as a result, the finally code block is not running. But with the ASP.NET Core application, when the exception is thrown, it still runs the finally code block before throwing the exception. With this code block, we're passing in the number that's not a number, we're capturing the exception and writing the exception message to the console application. It's then running the finally code block, but then we're throwing a format exception, passing in a number that's not a number. As a result, an unhandled exception is thrown and load is not set to false. And it's a similar story with the ASP.NET Core Web API. Passing in a number that's not a number, we're writing the message to the console application, it's running the finally code block, but then it's throwing a format exception. We get the unhandled exception, but once again, it's not setting load to false. In conclusion, the catch code block will only execute if there's an exception thrown in the try code block and it's the same exception specified in the catch statement. The finally statement will always run in an ASP.NET Core Web API, regardless of whether an exception is thrown in a try or catch block, or whether the exception is handled or not. But if an unhandled exception is thrown in the console application, the finally code block doesn't run. Exception handling in ASP.NET Core now has its own middleware. Watch this video next where you'll learn how to add exception handling to your ASP.NET Core app. It's essential that you use middleware to write a custom error message should an unhandled exception occur. By doing this, you're not giving away your application's vulnerabilities to a potential hacker who could use the stack trace to their advantage.